Mach 3.2 and 80,000 feet, which is the design point for the airplane. That's what everything that you see here was designed to do, was to be at its optimal performance at 2,300 miles an hour and 80,000 feet. So all of our design had to do with the heat that happens there too. Air crossing a Mach 3.2 shock wave goes from minus 45 degrees at 80,000 feet up to 800 degrees Fahrenheit. And as it crosses that shock wave, it gets compressed also. It goes from 0.4 psi, almost a vacuum, up to about 15 psi when it's entrained inside the nacelle. And so the engine enjoys seeing nice high pressure air, 15 psi, but it's also pretty hot. That 800 degree air is our cooling air. So what happens when metal gets hot? It expands. This engine literally grows 6 inches in length when it's at cruise, and 2.5 inches in diameter. So how do you design to take care of that? Those were some of the challenges that we had to overcome in making this engine actually work. So we have a little bit of titanium at the front of the engine, the first stage of the compressor. The rest of the engine are various iron nickel alloys. Waspaloy for the greatest part, some Inconel, one part that's made of an alloy called Astraloy, and that's how it goes. This engine has got a lot of firsts associated with it. It is the very first use of directionally solidified metal. In other words, metal in which the crystals all grow in the same direction. That's right here in the turbine, so that as the turbine blades are spinning, their growth rate is controlled. We know which direction to measure, and the stretch that happens over the life of the turbine can be measured, and we can take maintenance measures to ensure that the blades don't break. But they're very, very strong in that direction, which is what we needed. It's also the first use of self-metering afterburner spray bars and continuous afterburning. We have to, when we light off our afterburner, it can run for an unlimited amount of time. As long as we have fuel, we can run the afterburner. So that's another big first. You may have noticed that there's a little bit of plumbing on the engine. The engine has got 600 pieces of plumbing, 347 stainless, which is very easy to work with.